Hello, geometry students, and welcome to section 11.3. Today we're going to be talking about area of polygons. I'll go and get the PowerPoint up here and you can follow along in your notes. Maybe. Let's see, there we go. All right, so we have some warm-up problems today, so go ahead and pause the video, try to find the area of each of these figures, and then we will check. Okay, welcome back. So our first figure we have is a triangle. So to find the area of this triangle, we're going to have 1/2 base times height. So we should have 1/2 times 18. Oh, that's a nice 8 times 6. Let's see if I can make that look more like an 8. So 1/2 of 18 is 9. 9 times 6 is 54 inches squared. All right, on our second one, this is a trapezoid. To find the area of a trapezoid, we're going to do 1/2 times the height, which is 7, times the sum of the two bases. And our two bases are 10 and 4. All right, so I could multiply 1/2 of 7, which gives me a crazy decimal, or I could go ahead and add 10 plus 4 is 14. 1/2 of 14 then is 7, and 7 times 7 is 49. Remember, with multiplication, the order in which you multiply doesn't matter. So I did 10 plus 4 is 14. 1/2 of 14 is 7. 7 times 7 is 49. All right, number 44. This time we have a triangle again. So we're going to have 1/2 times the base, which this time is 13. That's a right triangle. The height is 9. This time we are going to get a decimal answer. 1/2 of 13.9. 1/2 of 13 is 6.5 times 9 should give us 25.25 inches squared. And again, the solutions are in the Student Journal Notes folder in Schoology. So if you want to go back and check the work, see how I got these answers, you can go there. All right, number 45 is a parallelogram. To find the area of a parallelogram, it's similar to finding the area of a rectangle. Our area is base times height, or 5 times 3, which is 15 feet squared. All right. On part B, it says, what is a regular polygon? This goes way back to the beginning of the year. A regular polygon is one in which all the sides are congruent and all the angles are congruent. So it is a polygon that is both equiangular and equilateral. All right, this time to do the vocabulary, you need to use your book. Find the meaning of each of these vocabulary terms, write them in your journal on page 326. You can use your textbook. You'll also see pictures of these things in the journal. Make sure you can understand the difference between all these different things, what the center of a regular polygon is, what the radius is, what the apothem is. That's a new term today. So make sure that you look at this. Notice it's apothem, not to be confused by an opossum, a little woodland creature. It's an apothem, right? It's important you understand the difference between these two. Central angle of a regular polygon, make sure you know that too. You need to add this to your notes on page 326. If you look on 326, you'll see a note space at the very bottom of the page. Be sure to add this. And it says to find the measure of each central angle of a regular polygon, you divide 360 degrees by the number of sides. So go ahead and take a minute, jot down the definitions to each of the vocabulary terms. I would imagine it'd be helpful to draw a picture of each thing or to draw a regular polygon and label the parts, and then come on back and we'll continue with the core concepts. All right, core concepts today, we have some new area formulas, area of a rhombus or kite. If it's a rhombus or kite, it says the area is 1/2 the product of the two diagonals. So here's a diagonal and here's a diagonal. So you multiply those together and divide by 2. Same thing if it's a kite. Here's a diagonal, here's a diagonal. Find those lengths, multiply them, and divide by 2. All right, area of a regular polygon, their area of regular n-gon, all right? So the n is the number of sides with side length s, and apothem a and perimeter p is 1/2 AP. So to find the area of any regular polygon, it's 1/2 times the apothem times the perimeter. Another way to write perimeter is the number of sides times the length of a side. So this part here, this n times s, is the same as perimeter. So 1/2 the apothem times the perimeter. All right, we have some extra practice starting on page 327. We're asked to find the area of this kite. Remember, the area of the kite can be found by doing 1/2 diagonal 1 times diagonal 2. So I'm going to fill in the numbers here. Diagonal 1, I can look, let's see here, this diagonal, I have 5 centimeters to this point, another 3 centimeters, or a total of 8 centimeters, times diagonal 2, which looks like I have 2 centimeters plus 2 centimeters is 4. So 1/2 of 8 is 4, 4 times 4 is 16. Again, it's area, so we're going to have square units. So make sure you put the units in there. This is a 4, by the way. It's kind of hard to see that. All right, on number 3, find the measure of the central angle of a regular polygon with 8 sides. This is what a central angle is. So here's my polygon with 8 sides. All right, that's an octagon, 8 sides. The central angle is if I go from, and I draw on these 2 radii, the central angle is the angle formed by the 2 radii intersecting these vertices here. So if I have 8 sides, the measure of the central angle is going to be 360 divided by 8. And if I divide that, I get that each central angle is 45 degrees. Right. There's several central angles in here, right? I could draw multiple triangles in here. Each one of those central angles would be 45 degrees. All right, number 4 this time, it says the central angles of a regular polygon are 40 degrees. How many sides does it have? So this time we're kind of working backwards. I'm going to take my 360 degrees. This time I'm dividing it by 40 degrees. And that will tell me the number of sides. I'm going to do that. If I do 360 divided by 40, I get 9. So how many sides does the polygon have? 9 sides. All right, number 6. It says a regular hexagon has an apothem of 10 units. Find the radius of the hexagon and the length of one side. So I'm going to find a center here. And again, an apothem goes from the center and it is perpendicular to a side here, and it hits it right in the middle, right? Central angles again. I'm going to switch my colors here. Central angles go from the center. If I connect these things, and this is a radius, right? Notice a radius goes to a vertex and apothem goes to a side. All right, so I have this little triangle. If I look at this hexagon, right, I can make 6 of these triangles within a hexagon. If I take 360 and divide it by 6 sides, each one of those central angles in this case has a measure of 60 degrees, right? All these sides are the same length. This is a regular polygon. So that means this triangle that's incorporated in here is an equilateral equiangular triangle, okay? Okay, so we have, these are all the same. So now there's a couple different ways to do this. I could find the area, if I want to know the area of the hexagon, I can find the area of one of these triangles and multiply by 6, right? Or we can use our area formula today when we get to this, 1/2 the apothem times the perimeter. All right, so it says find the radius and the length of one side. All right, so we know this apothem. So I'm going to go back and relabel this apothem length. We know this is 10 units. We know it hits this side. It meets it at a right angle. So draw that in there, little 90-degree corner. And now some of you may have noticed if these angles are all 60 and I cut this into a little right triangle, it is now turned into a 30, 60, 90 triangle that hopefully we remember from last chapter 9 when we had special right triangles. All right, so this angle up here is 30. Because we cut it in half. This angle is 60. And this angle is our 90. All right, we know this side is 10. Switch colors again. So there's our apothem here is 10. So that's the long side of a 30, 60, 90 triangle. Hopefully you remember to go from a long side to a short side in a 30, 60, 90. I would have to divide by the square root of 3. So this short side here is 10 times 10 divided by the square root of 3. The hypotenuse then is double this short side. So that would be 20 over the square root of 3. So that's going to help us answer some of these questions here in part A. Part A says find the radius of the hexagon. That's this piece right here. So I know my radius is 20 divided by the square root of 3. And again, we can simplify that. So that's our radius. The length of one side, well, if it's 10 times the square root of 3 from here to here, this short side, this entire side happens to be the same as this radius. So it is also 20 divided by the square root of 3. All right, so the radius, I'll fill it in here. The radius R equals 20 divided by the square root of 3. And we can remember to simplify these. We multiply top and bottom by the square root of 3. That's called rationalizing the denominator. So I would get 20 times the square root of 3 over 3. The length of one side is the same as that radius if you look at our picture. So the side is also 20 times the square root of 3 over 3. Remember, these are exact answers. If you want to multiply that out on your calculator, you'll get an approximate side length and an approximate radius length. All right, so these are in units. All right, part B says find the area of the hexagon. All right, so you could either find the area of this triangle, 1/2 base times height, and multiply it by 6, because there are 6 of those triangles contained in there. Or I would like to use today's new formula, which is the area of a regular polygon is equal to 1/2 times the apothem times the perimeter. All right, so I'm going to fill in the numbers that we know. 1/2 times the apothem. I'm going to switch colors here so I'm consistent with the color we've used all along. Our apothem is 10 units long. They gave that to us in the problem. To find the perimeter, I know here that each side is 20 times the square root of 3, 20 divided by the square root of 3. There are 6 sides, so I can write that my perimeter then is going to be equal to 6 times 20 divided by the square root of 3, right? Because there's 6 sides in a hexagon. All right, so I'll fill that in over here. If I multiply, and this is over 1, right? If I do that, I have 6 times 20 is 120 divided by the square root of 3. All right, so then I can do some simplifying here. I'm going to go back to my blue pen. I can write down here then that my area is equal to half of 10 is 5. 5 times 120 would be 600 over the square root of 3. Okay, if I simplify that by rationalizing, I'd have 600 times the square root of 3 over 3. 600 divided by 3 is 200, so 200 times the square root of 3 units. That's the area. Okay, if it bothers you have that decimal, that radical, we can make that an approximate answer, multiply it all out. 200 times the square root of 3 would be about 346.4, and our units were just units, so I'm going to write 346.4 units squared. All right, so that's how you find the area hexagon. I would have gotten the same answer if I had found, again, the area of one triangle, 1/2 base times height, so 1/2 times base 20 divided by the square root of 3 times the height times 10, got that answer and multiplied by 6. Again, there are 6 of these equilateral triangles contained in this hexagon. All right, that's the last part of today's notes. Your assignment is in the book if you're doing these in the book, or this assignment's also on Schoology, and you can complete the entire process in Schoology and get your score. Again, remember you get 3 tries for each homework assignment, so if you don't like the score you get the first time, check your work, try it again, and good luck.